So you could almost imagine that there's a conversation going on between a psychic and a detective to solve a murder mystery. And the psychic, the detective is at a dead end and can't figure out how to solve the murder mystery. And the psychic has this sort of amazing leap. Oh, you need to check the fingerprints on the body. It's maybe not that amazing of a leap. And you'll find that the murderer is Smith. Now, we wouldn't arrest someone based on just the word of the psychic. The detective now actually needs to go and check it out and see that it actually is true. And assuming that the psychic is giving checkable information and it's correct, then the two of them together should be able to solve the problem. Now, the role of the psychic here is actually to pick the accepting certificate, out of thin air somehow. Just guess it. And then the verification algorithm actually can check it. This actually explains, this notion of guessing a certificate, pulling it out of thin air, is not a deterministic process. It's not something that we could just program an algorithm to do, to just jump right to the right answer. And that makes it a non-deterministic step. It's not the kind of thing that you could actually write into a program that proceeds step by step by step by step. It sort of makes this crazy leap, non-deterministically. And as long as we can check that leap is correct with the verification algorithm, we can at least conceptualize that this is a way of solving problems. We can't actually implement a computer like this, but we can imagine a computer that we call a non-deterministic computer, non-deterministic Turing machine, that could do this sort of magical step. And that's where NP gets its name, non-deterministic polynomial time. Now, just as a quick aside, there actually are some researchers working on something like this. There's reasons to believe that a quantum computer can do certain kinds of guessing, essentially by, in parallel, kind of imagining all the different situations that all the different, say, certificates that might exist, and then designing the algorithm in such a way that the correct certificate will actually bubble up to the top and efficiently. This doesn't exist yet, so don't get worried that what you're learning in computer science is all completely irrelevant. It's still relevant for as far as we can tell into the future. But the idea of a quantum computer is actually very interesting. And we have reason to believe that the design and analysis of algorithms for quantum computer are going to lean pretty heavily on the stuff that we do for classical computers as well.